Okay. So all
And Miraj, you'll have to set up some time for me after the call probably to help me troubleshoot that. I'm sure
yes.
it will be troubleshootable.
Yeah, Girish, let's meet around. I'll send you the time. Let's meet around that time, and let's try to troubleshoot this problem. There's nothing great, I think. There
Super.
would be some problem which might be doing. Sure. So let's meet around 12 or 1 your time. I'll ping you what time, and then let's share your screen and see what is the problem you're facing.
Fine.
So there are things like partitioner, combiner. So let's look into the combiner before moving into the partition. Combiner is easy thing. So now, as you know that when the data is outputted from your mapper side, say for the word count example, we are producing word comma one, word comma one, word comma one kind of thing. So if there are 3 instances of apple in my record which has been processed by Mapreduce thing, or the whole split which is produced by Mapreduce thing, if there are 20 apples, I am unnecessarily sending the 20 key value pairs over the network. And that is slowing down my data processing because there is a network bandwidth which is also involved in sending the data from the mapper to reducer phase. So if I can apply a logic on the mapper side itself which combines my data to the intended format which is required by the reducer, I can reduce the network time which is required to transfer the data. So if I apply the same logic what has been applied on the reducer side, on the data which is produced from the mapper side, I can easily reduce my data transfer over the network. And what I mean by that part is, so if I do the summing on the keys on the mapper side before sending the data to the reducer, so if there are 10 instances of apple, instead of producing apple comma 1 apple comma 1 10 times, I can produce apple comma 10 one time, then send that over the network. So this will reduce my network usage and it will also increase the performance of my program because now I am sending less data over the network, so time consumed to transfer the data is reduced. So combiner is that thing which helps you to combine your data at the mapper phase before sending to the reducer. So in 99.9% of the cases, your combiner class would be same as reducer class. So in the configuration, all you have to do is, like we set the mapper class and reducer class, you set the combiner class also, and your combiner class would be same as reducer.class. You will not be creating a new combiner class, you will be using the same reducer class, and that will do the work for you. So a reducer logic is applied to your data which is produced from the output. So for each split, this reducer is applied, and at the reducer phase, again that reduce logic is applied. So practically apple comma 10 and apple comma 20 and apple comma 30 kind of things will be reaching a reducer from different mappers, and reducer will be summing this 20, 10 and 30 and will be producing the output for the word count example. So this is how the combiner was, and beware of using the combiners to the functions like say mean or mean would work. I think median. So median were these kind of if you are just finding out the median on the data, so at that case combiner could not be applied because median of 2, 3, 5, 6 and 7 would be 5, the midpoint of the series. So if you apply that thing on the combiner phase, so your median might get differ when you are really producing the output. But in most of the cases, when you are doing the aggregation kind of thing or things finding out something or doing reducing kind of thing, you can definitely use the combiner as your reducer class and then produce the output. Akash says, is it not a good practice? And then he says, okay, got the answer. Oh, good. You got the answer. So let me show you a practical example of combiner. Just give me a sec. My laptop has just rebooted, so I have to open the Eclipse also. Give me a minute. So So I'll just find out the class name and we'll show you the class also. So in the whole framework, all what we are trying to achieve is increase the performance and increase the performance. That's all. So same. So here we are just trying to reduce the data transfer and trying to increase the performance. We can also apply the compression on at different layers, and that will also increase the performance. So just after this, we'll be looking into file formats and compressions, different compressions which you can apply on your data sets, so which are by default available in your Hadoop world, and the file formats which can help you at different levels. So my Eclipse is up. I'll just share my Eclipse screen also. So let me get in combiner output. Is there a combiner? Okay, I can use the word count only. So here what all I have to do is job dot set combiner class, and the combiner class will be saved as reducer class. So I'm just talking about my word count program which I was discussing with you, and this is all. And if I use it and run this program, it will give me the same output as it was giving previously. And the beauty about this program is it will reduce the data transfer across the network. So this combiner logic would be applied on your mapper output, and these combiner output will then be sent to your reducer part.
But combiner logic should not be before reducer class?
It will be on your mapper data node.
Okay, but shouldn't it execute before the reducer class? Because
okay.
Combine.
Okay, so that was Akash, or that was Rohit, right?
Rohit.
So Rohit, this step does not matter here. What all we are doing in this class is just setting the configuration things. So I'm just setting the configuration. I'm not applying or running any logic over here. The logic is the framework which will run all these things. I am just setting the configuration for this framework. So this order does not matter. Even if I put it over here also, it will remain same.
Okay.
Okay, only the job object should have been created. Job object was created here. So even if I put here, it does not make sense. I am just setting the configurations to which will be used for my application or the framework to run.
Okay. So actually, when you invoke this method, their order matters, right?
No. So only the order will matter how you're processing the data. So this whole program where I'm just setting the configuration, it does not matter. But the order will matter if I am changing or playing with the data in my mapper class. So here if I'm playing with the data, the order matters because this will be running sequentially.
Okay.
But this, what I was showing it to you, this is just a configuration thing. So this configuration XML kind of thing would be created for you, and that configuration would be used to run your Mapreduce framework. So what your this this Mapreduce framework will do is it will just check. I'll put everyone on mute. So it will just check. It will just check whether the combiner class has been applied to my framework or not. If the combiner class is applied, it will just find out which is the combiner class and apply the logic, and then will send the data to your reducer part. So irrespective of fact where I'm setting this logically in my program, this job configuration thing, that does not matter. Only the thing which matters is I've configured that thing or not. So Rohit agrees, got it? Okay, Rohit says yes. So let's look into the partitioner thing. So what partitioner does is basically now, as you know, that there's something called sort and shuffle phase, and in the sort and shuffle phase, my data is bucketed based on the hash keys of my hash values of my keys, and based on that buckets, my data has been supplied to a reducer. The reducer which is intended or which is consuming the data corresponding to bucket number X, all the keys which have the hash value which is lying in that bucket will go to that reducer. So there could be the cases where I want to process or I want to change this hash logic based on my requirement. And with the help of partitioner, I can achieve that. So with the help of partitioner, I'll be implementing my hashing algorithm myself, and based on the hashing output from that algorithm, the reducer would be chosen. So this by this way we can easily achieve the we can basically play with the data, and we can create our own hash keys and compile the data to be going to a particular reducer which is intended to process that data. So I'll give you a practical example how that makes sense, and that will be more clearer to you. So just give me a sec. Let me switch back to Eclipse and show you one data set. And also I'll and before showing it to you, let me open the data file also, and that will make it more clear. So what we have to do is we have to somehow, in my data set, it's opening, just give me a minute. In my data set, we have age of the player name, player sex, basically male or female, and the score which he has achieved in his baseball match. So I have the output. Let me switch over back to the output file, input file. So this is my data set where the first column is the name, then the age, then the male or female, and the score which he or she has achieved in his match. So what I have to do is I have to find out the score in particular age groups and the maximum score of male and female in that age group. So the first age group is less than 20. So the players less than 20, I have to filter out those players and I have to find out the maximum score achieved by the male in that age group and the female in that age group. And similarly for 20 to 50 age group and then 50 plus age group. So these are the three groups on which I have to find out the male and the female names who have achieved the maximum score and the corresponding score. So can anyone think of how I could achieve that without using partitioner? Then I'll show you how simple it becomes to solve this problem with the help of partitioner.
So I'll probably use the age as the key and
sorry, probably use age as the key, okay?
Age as the key and try to sum.
So I've just placed this data over here for the reference. So age as a key, so it will 23 and your data. Something like this you are saying?
We can't see your Excel.
You can't see my Excel. Now?
Yes.
So something like this you are saying?
Yes.
And then?
And then try to... Sorry, I'm lost. Go ahead.
I think take age as key and then score and do a sorting, and once you have done the sorting you have those categories clearly available.
No, but
Next to column.
but my problem is I have to produce output something like this in each age bracket. So less than 20, 20 to 50, and 50 plus. So first thing which I have to find out is all the ages which are less than 20, and in that ages less than 20 I have to figure out male and female both who have achieved the maximum score. So if I look at the less than 20 ages, so this and okay, these things. So my output would be Nancy as a female and Adam as a male. So this is what I want in the output. For one age group, that is less than 20. Then similarly for the other age groups. Any guesses? Okay, so the easiest way is to use partitioner. Let me explain you how it easy that is achievable with the Mapreduce also. All you have to do is somehow create the so basically we have to play with the data in mapper and reducer part. So create the age group as the key. So these are the three keys which will be produced from the mapper side, and with this key this data would be outputted from your mapper, and similarly with the other keys. And when this data we are processing on the reducer side, we have to make a counter, or we have to basically put some if and else, and we have to segregate males and females and figure out and keep the maximum value of male and female both, and print that output. Does everyone agree with that part? That can be achieved, but we have to put a lot of ifs and else in the reducer part and have to play with the data, and then only I can achieve that part. Okay, I'll just assume a yes from everyone. But how that could be achieved with the help of partition, let me tell you. So if I can plot.
But Miraj, just one thing.
Yeah.
So you told, I mean, in mapper and reducer, mapper, shuffle and reducer, there will be key and value pair, right?
Yes.
So if we take here, first key is the age range, right?
Yeah.
And after that, value is so big actually, right? Value has, I mean, word, then one integer, then again word, then value, right?
Yes.
So are you saying that we are choosing key value, and then doing a string operation on the value part to reduce it, right?
Yes.
Okay.
So this will become your key and the value will become this, and similarly for other data.
Okay. And in reducer, basically we are again parsing the value.
Yes, and find out males and females, and then dealing with the data. So we are putting some if and else in the reducer part, and then really playing with the data to find out males and females and things like that.
Yeah.
So, but how that can be achieved with the help of partition? Let's look into that part. So as I was saying, this partitioner helps you to produce an output or the hash code of your data. So what I can do is, if I can assign a particular hash code to this data, which is intended for reducer 1, and some particular hash code for this data which is intended for reducer 2, and some particular hash code for this data which is intended for reducer 3. So I am ensured that all the values which have age less than 20 will definitely reach my reducer 1. And if I create the key and value pair output from the mapper, something like this, male as the sex as the key and value as your age. So in the reducer part, all I have to do is for 2 keys, I have to just find the maximum. So on the reducer, I have to just write a simple logic. Whatever key is coming, I am not worried about that. I have ensured that my particular age group keys are coming, and the keys is just male or female. So 2 keys will be going to this reducer, 2 to this reducer, and 2 to this reducer. And this reducer will just find out and this reducer will just find out the maximum of both the key, of a key which has been sent to it. So this reducer in this case for this data set will receive two keys. One is female and one is male, and this female would have two data sets. If I'm passing the whole data, I can also pass the part of the data. So right now I'm just showing you the whole data and this thing. So in this reducer, all I have to do is just find the max on the age, nothing else. And similarly for the male reducer. Make sense to everyone? So this is the key and this is the value, and similarly for male, key and the values, and similarly for other reducers also. So Akash says yes. Avidas said it long back. So this is how I can my partitioner helps to partition my data. So let's look into the code, and don't worry about the technicality of the code, but try to understand this concept. This, if you have this in somewhere in your mind. Yeah, Avidas, go ahead.
Okay, I thought talking was faster. So what's the difference between column G and column H here?
Column G and column H. So column G, I am just saying the reducers which are in my program. So there are three reducers which are created in my program. One is R1, R2, and R3. And this this reducer will get only two keys. First key would be this thing H, and second key would be this thing. And similarly, the other reducer will also get only these two keys. From the mapper phase, I am producing keys as sex and the values as the corresponding age and name pair.
Well, can't column H also be a reducer? So let's say we already have R1, R2, R3. If we have R4 and R5, and we just do a cross of R1 versus R4 and R1 versus R5, and get our distinct two records, Nancy and Mary, like that.
Sorry, could you please elaborate? I am not able to get you. I have reduced.
I'm saying
R4
just like you created less than 20 as R1, can we not create female as R4 and male as R5? And then just do a cross, M into N, relation, and get all the unique ones, unique combinations out.
Okay, so what you are saying is, okay, so we have to think in the data in terms of how much overhead we want to create and how much overhead we want.
Exactly, this is what I was coming to. Why did you create them as keys, column H, male and female as keys, and you decided them to R1, R2, R3 to be reducers?
Okay, so what my problem statement is, I have to find out the maximum score by my male and female in each age group. So if I have to find maximum on some particular thing, if I make that is a key on which I have to find the maximum. In the reducer part, I have to just traverse all the values and to find out the maximum value, and I have to print that part. Do you agree with this thing?
Yes.
So but the problem is, if I create a key as male and female only, then I can't guarantee which age groups will go to which reducer, or there will be a single reducer and which could be dealing with all the age groups. So in that case, I'll just mute you, Rohit. Okay. So in that case, if all my data goes to reducer 1 only, or there are only 2 reducers kind of thing, so in that case, I can't ensure that I am able to find the maximum of my age group.
Okay, my intention of this question was something else. I'll just switch. If I would switch H with G.
H with G.
Like
so G
have to only R1 and R2 and have 3 keys, less than 20, 20 to 50, and greater than 50.
Yes.
Is that something to do with overheads? Is that a decision we make ahead of?
Okay. So you are saying rather than this, my key is this. This is what you're saying?
Yes. Yes.
Yes. So yes, definitely your key can be this thing, and that is what I said. I can achieve this solution without using your Mapreduce or without using a partition. And in that case, what you have to do is you have to create your key something like this. But in that case, for this key, I'll be getting my whole of this data over here, and these will be the values in this key, the list of values. Okay. Now, if I say a maximum of the score which I have to find, I can produce only one output until and unless I apply some ifs and else's in my reducer and filter out males and females and then find out maximum of that.
Well, if you have R1 as female and key as less than 20, you only have two records.
Okay.
You know.
Okay. So you are saying, okay, I'll come to that part also. So say you are saying just you have two reducers. Oops. Just two reducers, and the third one does not exist, and this is your male and this is your female. But somehow I have to apply a logic so that all the males reach your R1. How I can apply that?
String check. Huh?
Sorry?
String comparison?
No, but from the mapper you will be just producing the keys and values. If you have created the key as age group, you can't have two keys from the mapper side.
So Miraj, I think, sorry.
Rohit, you were saying something? So Abhijat, somehow you can't create more than one key from the mapper side, and if you have created the key, the reducer function will be called for that key and the corresponding values. So, but here we have to segregate our data on two factors. One is on age group and another one is inside that age group, male or female.
So Miraj, I was saying what Abhijat is saying. I mean, that's a different way of doing value, right?
Yes, that's a different way. So rather than creating three reducers, I can definitely create two reducers and you pass them as the age group. Yeah, that is also achievable, and that is also another way of doing this. But I have to apply the partitional logic over here to make sure that all the males reaches reducer 1 and all the females reaches reducer 2.
Okay, but what Abhijat is saying, if you have to achieve that, what about if we do in mapper and we map male and female, we take out male and female as two keys, and then rest of the data we send as value, and then next set of keys we derive in either partition or in the reducer logic.
Yeah. So that is what I'm saying. You have to apply some logic in between your mapper and reducer to segregate these keys. If you create a key as male and a key as male and female, then all your data related to that male will be going to your reducer function first.
Okay.
And then over there you have to create a key on age group.
Yeah. And it looks like to be pivoting concept, right? Which we do in Excel sheet.
Pivoting. Yeah, you can say you are searching the data.
Yeah, it's all about finding a unique combination for each age group and gender.
Yes.
So whether we take the age group first or we take the gender first,
that's all.
Partition. I'm just trying to understand, why do we make the choice of doing the age group partition first? That's what I'm trying to understand.
Okay, so both are similar. It's totally depend on you what you want to choose, but what you can think of before choosing the key and value pair, or what you can choose before how your data should be partitioned is. So say if my data set is too huge, I can, if my data set is smaller, I can choose the two reducers only because I am not giving the overhead to reducer parts. If my data set is bigger, I can think of choosing the three reducers or three buckets. So it depends on you how you want to choose it, but these are the two ways to achieve this solution.
Okay, that makes sense. Now there's one more related question. Is there also is it also something to do with whether I'm doing a string comparison or a number comparison? Like I would imagine a string comparison is slower than a number comparison.
Yes, a string comparison is always slower than number comparison, and here also on this age group also I am producing the keys as 20-5 and greater than 50 kind of thing. So here also I am doing practically the string comparison also. So yeah, if you look in terms of Oracle or databases, or even in the programming language like Java, the string comparison will be some microseconds slower as compared to your integer comparison, definitely.
Okay, I keep getting questions. I don't want to stall the class on this. But really the last one is, how are you doing string comparison when you do age 20 to 50? It has to be number comparison.
What I'm producing keys as is something like this. So this will be a one. This will be a one key. So this is string only 20-50 greater than 50. This is string only. So these are the three strings which I am producing probably I think in my program. I'll just really check it. But this is the kind of a string which we are producing in our program as a key.
Okay. Okay, that's thank you.
Sure. Okay, so let's switch back to the program and let's look into the program. So here what I'm doing from the mapper side is I am just producing the key as gender and the text as name, age and score. And on the partitioner side, I am partitioning the data based on, so okay. So with that I implemented your solution only. What I was talking in the Excel was the other way of the solution. But here I think I have implemented your solution only. I just cross check what I implemented. Yeah, there are three. So the key is gender only, and the text is name, age, and score. In the partitioner side, I am partitioning my data based on age group. So my key was gender only, and there are three reducers which are triggered for different age groups. So if the age is less than 20, I'm returning hash value as 0. If the age is greater than 20, I'm returning the remainder of number of reducers and 1. And if the age is otherwise, I'm returning reminder of 2 from the number of reducer tasks. And number of reducer tasks I have explicitly set in my main program, that is my configuration, is 3. So there are 3 reducers which will be triggering for this program. One reducer will get any one of the reducer might get less than 20. One reducer will get 20 and 50, between 20 and 50, and the third reducer will get greater than 50. And in the reducer side, all I'm doing is I'll get the key, and on the key I'm just finding out whether this score is the max score or not. If this is the max score, I'm just if this score is greater than the max score which I have stored, I'm just using that value, and at the end of looping all the values for a particular key which I will pass to this reducer, I'm just printing that part. So Abhijat says, even before returning the hash value for the age group, can you please show where is the gender selection done? Okay, so the gender selection is done over here. So here I'm just parsing my string based on tokens of /t and finding the third token, that is the gender, in my data. So Rohit, the reducer is your new JVM process which is initiated to process your data. Reducer's reduce function would be called for each key and value pair separately for all the keys which it will be processing. So this, when I'm saying 3 reducers are created, the values, how these values are distributed to these reducers is based on the age group category. But each reducer will be getting the data for 1 key male and for 1 key female. and this reducer's reduce function would be called twice for each of these keys, map and male, and one time for female, and that's the reason so your reducer's reduce function will always be called for all the values which are intended for this reducer and for each key. So here I've created the key as gender, and I am distributing my data to different reducers. Does that make sense, Rohit? Okay. So this is the important thing which you have to remember. Your reducer's reduce function could be called many times. Similarly, mapper's map function would be called many times based on number of records, and reducer reduce function would again be called many times based on number of records which are intended for that reducer, or the map keys which are creating the hash code which is intended for that reducer. Okay, so let me switch back to okay, let's try to run it. So I'll just copy the class name. At the end of each program, I've also given the hint also how to run it, so that you have all the classes, and the data is also there shared with the code only with you. So if you want to play with the same data, the data is also there in the same code folder. There's a folder called data inside the code folder, and so before that I'm just deleting the output folder. So Rohit says here, when we invoke three reducers, we invoke three jobs or three tasks. So Rohit, the job is one only, but the tasks are practically 3 plus number of your mappers. So now the number of mappers will depend on your number of splits. So number of splits plus plus 3 reducers. So these are the number of tasks which will be initiated in your program. So it's running. Let's go to the output directly by the time, and let's check that. So I'm switching over the control, switching over to the output directory. So it's just processing, and it's in last stage. Okay, so it's done. So let's see, the output directory is there. So output directory is there, and see three files. I hope everyone understand why there are 3 files now. Yeah, everyone says yes. So now if I open any file, so see this file, this reducer got the age group of less than 20, and it has produced the Nancy and Adam as the corresponding maximum scorers of that age group. So this reducer has got 20 to 50, and it has produced the corresponding outputs, and this reducer has got greater than 50. So this is how we can partition the data based on our hashing logic, and can play with that data to produce our intended output. Okay, let me switch over to PPT. Any questions on this part? Okay, so as I was saying you, we have to just set the partitioner. So conf.set partitioner, I have to set the partitioner, and that's the way I can achieve my segregating my logic to the different reducers. So over here, if you see from the mapper side, the data is going to a partitioner, and partitioner will basically partitioning your data or finding out which color is intended for which reducer, And this is the way I've created my own colors, and my own colors are going to my own color reducers, as I was showing you in the color example in my Mapreduce program. So after that, there are different compression technologies which you can apply at different layers also. So we'll talk about these compression techniques in the next PPT. I'll just open that PPT and nothing else. Okay. So I'll open that PPT and we'll talk about the different compressions which are available to us. Just give me a minute. Let me open another PPT.
So Miraj, I missed a little bit. Why?
Sorry, Rohit, I can't hear you.
Miraj, my question was, why is compression used?
Yes, I'm coming to that part. Why is compression used? What are the benefits of compression, and where all we can apply compression? At which phases of Mapreduce we can apply compression, and what are the benefits and disadvantages which we'll get by applying compression? I'm just coming to that part. Give me a minute. I'm just opening a PPT and I'm coming to that part. So I hope you can see my PPT. So these are the three layers where we can apply compression. We can compress our input files. We can compress our output files, that is an output produced from the reducer. We can also compress the data which is produced from your mapper and is transferring over the network to your reducer. So these are the three phases in the Mapreduce cycle. And these are the three inputs or outputs of the Mapreduce cycle, and we can apply compression at all of these three phases. All we have to do is just set the configuration things and the compression codec, the compression algorithm which we want to apply. So coming to our point, Rohit, let me explain you what are the benefits and disadvantages of compression. So I'm switching back to an Excel sheet to discuss those things. So this is your file on which I can apply the compression. This is your map output, and this is your reducer output. So at three layers I can apply compression. So let's talk about the compression. So advantages and disadvantages. So can anyone tell me what do you think are advantages of applying compression to the file which I'll be reading in my Mapreduce phase? Just try to think of in different directions what could be the advantages. Abhijat says faster reads. Yes, definitely my IOs will be drastically reduced and my read will become very fast, and that is a major advantage which I get by applying compression on my data. Any other advantages? Yes, of course, less disk space. So if I have say a text file and if I apply a compression like gzip, I'll talk about all these compression things. But if say I apply a compression and the compression can reduce my file up to 80%, so practically I have not saved. So for a 100 GB file, if I compress it to 80%, the file will become just 20 GB. So practically I have not saved 80 GB. I have practically saved 80 into 3. That is 80, 160, 240 GBs. So practically, when I apply compression on my data, I'm practically saving thrice the disk space. So I'm saving a lot of disk space. So and Girish says lesser bandwidth use of the network. Yes, Girish. So if there are some spills over to data blocks and things like that, there are definitely lesser bandwidth uses or the data transfer is less over the network if there is the split is across data nodes and things like that. So now there is a disadvantage also. If there is an advantage, yes, Rohit, I'll just explain you that part. The compression is applied at different layers, how that is applied, and to where that is applied. Just wait for 3 more minutes. I'll explain that part. So, what are the disadvantages? Yes, processing. It becomes CPU bound. So also Grish and Abhijat also was saying the same thing, but in different terms. So Abhijat and sorry, Akash was saying the same thing, but in different terms. So they become CPU intensive. So CPU usage increases. So I reduces the IO, but I increases the CPU usage. Yes, definitely the Rohit, the extra logic. Data might get corrupted. So Greece says data might get corrupted. How do you think, Greece, the data would get corrupted by compressing? I am not able to get your point. So so Greece can ping me in the back end. By the time, let's talk about. Okay, so Greece is just thinking all the possibilities. So now I'm just compressing the data. That will not corrupt my data. If my data is getting corrupted by compressing, I'll never use the compressing algorithm. So yeah, definitely it becomes CPU intensive. So then let's think about what are the advantages if I apply the compression on the output of MapRed, what is being produced by out of my mapper, and that has been sent to a short and shuffle phase and transferred over the network to the reducer phase. So definitely I buy again this point which Grish was saying, and IOs are also reduced if your data is spilled over to disk, but the disadvantage is CPU intensive. And over here also the CPU intensive, and definitely these things. Does everyone agree with all these points? And Rohit, I'm just coming to a point. Okay. So looks like everyone agrees with this point. So this compression on the file will definitely, when we are storing the file into our HDFS system. So while the file is been coming to our HDFS system daily or one-time imports or whatsoever is the kind of thing, I have to compress that file. So whatsoever is my importing mechanism, I'll be applying the compression over there so that while the file is placed in my HDFS, that file is compressed. But to these two phases, while reading the data from that file, basically when this file is read and given to Mapreduce thing, I have to just define in the job configuration that my file is compressed and the compression algorithm is so and so, so that while I'm reading the data and the data is being passed to your mapper phase, the corresponding decompression algorithm is applied and you are able to read the data. And if I have to compress the mapper output, or again I have to just set in the compression, set the job configuration that map dot output dot compress. So I don't remember the exact number that is there in the slide. Is equals to true and the compression algorithm. And similarly for the reducer phase. And this is a way I can achieve compression at different layers in my Mapreduce. So do you agree that if we apply compression, we get some advantages, although my system becomes CPU intensive, but there are other advantages also, and we should always think for compression on our data, because when we are dealing with terabytes and petabytes of data, and practically I am not storing petabyte, I am practically storing petabyte into three data. So my data storage capacity across the data nodes is very high in these clusters. So we also have to think in terms of reducing the space cost. Otherwise, your credit card bills will increase highly. So there were days when we were paying $1 million per month just for the cluster maintenance. To rack space. Abhijat says like CPU. Yes. Yes, Abhijat. So you have to check. Okay. So I was talking about the Ambari. So over Ambari we can see all these things. Okay. So I'll come back to compression part. I forgot to show you the Ambari part. So Ambari is available on the port 127.0.0 and 8080. So this is the cluster management or admin part of your Hadoop cluster. And here you can, so the user ID is admin and password is also admin. And the port is 8080 if you want to open it. And by default, this will be disabled for you. You have to just enable it from the UI. And once you enable Ambari, it will be, you can browse this URL. So there's a single node cluster. But here I can look into different statistics of my cluster. So here I can also see the CPU usage at different nodes, the whole cluster and things like that. So if I see the CPU usage is not too high, my processes are not very much CPU intensive, and I am just wasting the CPU processing power which I have brought for my cluster, I can definitely think of higher compressions. So based on the statistics of the cluster and different factors, you will be precisely choosing the compression algorithm as well as the layer at which you want to apply the compression. That's a perfect point which you have made. As we are doing the parallel processing, we might not be fully utilizing the CPU, and we are just storing, and our cluster is just becoming the dumping data dumping playground. So if our cluster is just becoming the data dumping ground, and we are not fully utilizing the CPU users, we should be definitely thinking of compressing our input files, so that it also utilizes the CPU bandwidth, and we can reduce the cost of our storage space. So before going to that part, again to the compression, let me quickly browse you to the Ambari UI. But before that, let's take a break and then browse this Ambari UI. And Rohit, did I answer your question? Kamaljit, I'll come to you. Rohit, did I answer your question, or did you had something else?
No, Miraj, my question was data compression when you talked about saving the storage, right? So it should always happen at the time of writing to the disk.
It's not only at the writing to the disk, that's what I'm saying. The reducer output is also stored into HDFS also. So the process data is again stored into HDFS. So if I do compression at that level, I am saving the disk space.
Yeah, so again at that time you are writing a file, right?
Yes.
So whenever you are writing, whatever process writes a file to disk actually, before writing we apply the compression and we reduce the disk space, right?
Yes.
Otherwise, if we have already written 100 GB files and 3 copies, right? We have already occupied the disk space. Now, after reading 100 GB, we apply the compression and then we make it 20 GB and then we circulate this 20 GB. That will reduce maybe network bandwidth, right? But not the disk capacity advantage.
No,
that will not be there.
If you have 100 GB, if you have a cluster of say 100 terabytes total space across the data nodes, and you are almost going to fill up your space, and you have already consumed 900 terabytes, and your Ambari UI is showing red on each data node for the space utilization. So in that case, all you have to do is you have to read your data, compress it, and push it again to your. Basically, you have to compress your data. So once you compress your data, the older data you will be definitely deleting. You are just compressing and deleting the older data. So your compressed data is only in your HDFS world, and if the compressed data is already, so that's the same like you right click and zip a file in Windows and then delete the older file.
Right. Okay.
So Abhijat and Kamalji, I will just show you why you are not able to see this Ambari UI.
Miraj, just one question.
Yeah.
I understood whether it can apply at the input file side or reducer side, but how would this apply at the mapper side? Because mapper writes just the temporary data set.
So yeah,
you are saying that.
So that's what I'm saying. There are different advantages and disadvantages. On the mapper side, what I said is it reduces your network bandwidth or it will basically make your data transfer from the mapper to reducer phase fast.
Okay, okay.
And the mapper output is not stored in your HDFS, it's just stored locally on the node. So there it will just, for a temporary, it will just save some space, but it will reduce the IOs because your mapper output is also spilled to the disk on which mapper on which data node this mapper is running.
Okay.
So Abhijat and Kamaljeet, your Ambari is disabled from here. You have to just enable it. This button would be showing enable for you on the Hue UI. Just enable it, and it will take a minute or so to enable Ambari UI, and then your Ambari UI would be enabled for you.
That's accurate. I could see the enable button on it. And at the same time, I posted the message earlier which says there's increase the RAM size to 4 GB. Is it okay to have 2 GB and enable that?
Okay. Sorry, Kamaljeet, I've not tried that. Just try it out. I'm not sure about that, but probably that should work. But I am 100% not sure. That should work. That might slower up, but that should work probably.
Okay. I would go ahead and enable it.
Yeah, just try it out. I am also not sure about that part, 100%.
Okay. Hey, so one other question. On the chat window, I did posted 2 different URL.
Okay.
So
I might
the
have
first
missed it.
URL, which is 127.0.0.1:8080, that is taking me to HTTP 2.1 sandbox, and it shows a kind of architectural area. Is it something coming up with Hadoop, some kind of website which is available at my local, or what exactly is this?
Is this not the UI like this?
No, you remember in my laptop
Yes,
we
yes,
have set up
yes,
a
yes.
different VPN.
Yes, yes, yes.
So I have 192 which is working fine as expected, but I'm not sure what is 127 doing there.
So that's what I was saying. That either your some other process is consuming those port on 127. That's the reason you are not able to connect on that port on 127. So either some other process or what you are saying. I'm not sure what you are saying over there. So if you can just show me the snapshot, I can guess what could be running over there. If it's something.
If you over the break, or if you could share the screen share,
Okay.
I could show you the same.
Okay, sure. So let's look into that just after this break.
Okay.
Sure. So I'll give you the control after the break. And Rohit, I hope I answered your question. Okay. So let's take a 10 minutes break. This is 8:33 in my watch IST. I'll be back around 8:44 IST.
Thank you.
Miraj?
And I'm back. So Abhijat is also back. Gorish. So Kamaljit, are you back? Let's quickly look at your screen before we go ahead.
Yes, I am in.
Okay, I'm just giving the presenter right.
So, two things. One, I was talking about this particular website. So this is 127.0.01888.
Oh, 1 second.
And the site looks
Just,
like.
just go down. Yeah, go down. So okay. So this is just your that's listing. Your HotelWorks VM sandbox is only listening on this. So you can browse all the tutorials and things like that. And if you see, yeah.
So these are the two different websites. I understood that when my this box is running, my VM, is it something with this particular box is going over there,
No,
which is 127?
No.
So what is this thing?
This website is sandbox website only, and this is the front page of a sandbox website, and this is getting started, more resources, tutorial. This is some application which is listening on this port only. You are opened 8,
Yeah.
8, you have opened 4 times 8, right?
Yes.
Okay. This HotelWorks was only listening on this. Just give me a minute. Let me check. 4 times 8. Who's listening on that port?
So this was one thing. And second thing, enablement.
So it looks something like this. Support 8, 4 times 8 looks something like this. So I hope you can see my screen now again. So Kamish, I'll give you the the control back in a minute.
Okay.
So why I'm not the presenter? So everyone can see my screen. Is my screen visible to everyone?
No.
No.
No, we don't see your screen.
Okay. Now can you see my screen?
Yes.
So I think there's some, so this is again enabled on your sandbox only, because on 8888 there is an option directly go to a sandbox, and this will take you to 8004. And it's also Ambari, you can enable the Ambari from here. and also it talks about different things. So this is some small web UI which is enabled on this 8888 port, which is listening for your sandbox.
Okay.
And there are
that's
different,
a good thing.
so there are different tutorials also which is there in the sandbox. So all those tutorials are also browsable from 8888 also, and those tutorials are browsable from your 8000 UI also. But from here also you can browse all those tutorials. So you can just open those tutorials and can read about them. So they are talking about how to run a big program, high program from the UI and things like that. And the second thing you were asking about enabling the Ambari. So try to just click on this button, and I hope that would help you.
Which button, sorry? Enable?
Enabled it, yeah.
Yeah, so I clicked enable before going to the break. It's already 15 minutes and nothing is happening there. You says I should check with 8080. So that's what I am trying with.
No, but 8080 would only be enabled once your Ambari is open. So once your Ambari is enabled, then only your 8080 port Ambari would be listening on 8080. So after your Ambari is enabled over here, then only you would be able to see anything on that 8080 port. So wait for some more time. It might take some time to enable the Ambari over there. Just wait for some time. It will enable the Ambari, and once the Ambari is enabled, you will be able to see something like this on 8080 with admin as a user and password.
Okay, so one last question in the same regards is, what was the problem that we all have reduced from 4 GB to 2 GB on our laptop on VM total utilization?
So I think your PC has only 4 GB of RAM. So if you dedicate all the 4 GBs to VM, your PC would be scarce of your other programs would be scarce of the memory. So that's the reason I told you to reduce it from 4 GB to 2 GB.
Okay, so even if we keep it 4 GB, that's okay. It's a compromise to other applications.
Yes.
Okay. At least for the weekend, I could keep it 4 GB.
Yeah, or at least 3.5 GB, so that half a GB is there for other applications, and try with that.
Okay, sounds good.
Okay, so this is how your Ambari UI would look like, and there are different things which you can configure over here. You can look at the system statistics on the front page, then you can look at the different services running in the cluster. So Yarn, Mapreduce, HBase, Hive, Web Catalog, Uzi, Ganglia, Nangyo, Cooper, and different services. You can stop them all, you can start them all. So this will ensure that the services or the client of these services, if they are running on particular nodes and data nodes and things like that, so everything it will maintain. You have to just stop and start from here. You can set all the configurations of the system. So I hope now everyone understands the HDFS part. So the HDFS related configurations are available over here. Like the name node Java heap, secondary name node, data node, the custom site, and HDFS site.xml talks about the different configurations which are used for HDFS part. So this is user related configuration which is configured over here. We can add other configurations. HDFS talks about the replication and things like that, which is really related to HDFS. And the Yarn I have not covered, so I'll show you the Yarn also, but we will cover it probably might be in the next session. So here the Yarn related configurations are there, Yarn related, so I can directly change the custom site.xml for Yarn. So this custom site.xml, yarn site.xml, HDFS site.xml are the configuration files which are lying at your backend in your cluster, and either you can go and manually change them over there, or you can change it over here. And the beauty about changing over here is this XML is changed across all the data nodes in your cluster. If say there are 100 nodes in your cluster, either you can go physically on those 100 nodes and change this XML, or you can change it right over here. So all the parameters you are configuring over here will be transferred to all your nodes in the cluster. Here we have the Mapreduce related configurations. We have things like, I'm not going in detail on these configurations, but if you have any questions, ping me. I might be able to help you right now, but I'll cross check those things with my admin experts and then can get back to you on those things. So here, if you can see, I'm talking about the Mapreduce side, Mapreduce configuration. What will be my Mapreduce JVM heap size? What would be my spill size? Spills I was talking about. There's a spill. So how much if the data becomes more than this? If I have to spill on disk and things like that. And then I can go to the UI, the resource manager. So I'm not talking about the resource manager also, but it's similar to your job tracker. So I can browse the different jobs, which ran in my system. I can go into individual jobs. I can look at their history. I can look at their logs. So this is the old job. I can look at the logs. I can. So this also talks about my CPU users in the cluster, how much is the total memory in this cluster, how much are my containers. I'll talk about these containers. These are all related to yarn. There's a little difference between the job tracker and task tracker and the yarn management. So I'll talk about those things, but this is how I can browse it. Then I can look at the different hosts. So right now there's a single node VM, so all of these are visible over here. But if there are different data nodes, all of them would be visible over here. I'll show you that in my cluster. I have to connect to VPN for that. So either at the end or I'll show you the real cluster. That will be also the same, but there will be some differences. The different data nodes will also be visible to you, and the process is running on that data node, the state about that data node. So they are one alert in my system. Then no heartbeat 0, all these things, master nodes, health, the space uses of my data nodes, different data nodes, what is my current space uses, services I've already shown you, admin UI, I can create the users and security alerts and things like that on my cluster. I can maintain the cluster. So all the things which is related to admin world can be easily configured over here, and you can browse it via this UI. So this Ambari UI is also helps you in the cluster installation. So rather than installing each and every individual component and configuring that, you can just click next on the Ambari UI and set up your whole cluster with the help of Ambari, rather than doing all those things manually. So this Ambari UI is for your administration and maintenance of your cluster. Try to browse this UI. You will find many of interesting things over here. Many of the interesting configurations which you now can relate why they are lying at different sections, what sense they make. And if you have any questions, do let me know. I will try to resolve them. Okay, shall I go back to the PPT?
Yes, please.
Okay. So we can apply compression at different layers or at different places of Mapreduce program. So as I was saying, increasing the compression increases my CPU uses. So this I will gain at some layer. I will gain somewhere. I will lose somewhere. And that will so I have to precisely think of what kind of compression I want to apply and at which phase I have to apply. So for applying the compressions to the output file, I have to just set file output format as a compressed.job output to true. So this will enable the compression of the reducer output and the compression codec. So I'm using gzip codec over here. I'll talk about this gzip codec also in a minute or so. And if I have to set the compression on the mapper output, I have to just set mapred.compress.map output to true and the compression codec which I want to apply on the map output. So for the reader also, I have to just define the same file input format and the compression input and the compression codec for the input also. So same way I can apply the compression. All I have to do is just set in the configuration of the job, and everything will at the back end will be taken care for you. So we can apply the compression at the record level, we can apply the compression at block level, and if there is no compression. So we can also apply the compression at different levels also, record level and the block level. Let's talk about the different compressions which are by default available for you in the So gzip is the compression which is the default compression. bzip2 is a so gzip and bzip2 are compression which gives you high compression level. So they can even compress your data to 70-80% of your original data sizes. But as they have higher compression, they are high CPU intensive, and we have to decompress the data. So we have to spend some extra time in decompressing and compressing the data while dealing with these compression algorithms. LZ2 and Snappy do not achieve high compressions as compared to gzip and bzip, but they are faster because they are not compressing your data to such an extent. So they normally compress your data by 30 to 40 or 50% based on your data, also based on your compression algorithm also. But the interesting thing which you should be looking over here is splittable. So now can anyone tell me the benefit of using bzip over gzip? My bzip is splittable, however my gzip is not splittable.
So gzip is not useful for bigger than 64 MB files?
Yeah, you can say that. Yeah, I think that's one of the correct answers. Data fetch will be increased in bzip. Yeah. So Kamaljeet, I'll just read your comment. So yes, if your block size, if your data file is greater than 64 MB or your block size, you are creating a single mapper on that, and you are doing a processing with just one mapper because number of splits is equivalent to a number of mappers. And if I am creating a single split on my whole file, which is a big file of gigabytes or petabytes, I am just processing that file with single mapper. So Kamalji says data fetch will increase in BZ. Data fetch will increase. How the data fetch will increase? I am not able to get a point, Kamalji. So that's so now if you understand, now you can understand what is splittable. So now you can think in that perspective, and that's the reason I was keep on saying just try to understand the concept. Don't worry about the Java complexities. You will not be using that, but you will be using the concepts later on. So if your file is splittable, there is only one mapper which is created, and if the one mapper is created, you are not really using the parallel processing of the system. And similarly, LZ2 is splittable if it is indexed, and Snappy is not splittable. So you have to also think of which phase you are using which compression, and if you are using which compression, if the file is not splittable, what are the benefits and disadvantages you are getting. So bzip is or maintains some header records and things like that, and that's the reason the files are splittable in bzip as compared to gzip. So gzip is naturally supported by Hadoop, and it compresses your data highly. But as compared to bzip achieves more compression to the file. But this is highly CPU intensive. The CPU usage of a cluster will increase highly if you use this algorithm. So you have to also ensure what is your CPU bandwidth in your cluster, and based on that use the algorithm precisely. So as I was saying, bzip compresses more efficiently than gzip, but is slower. So Kamalji says, are the compression format depends on PIC, Hadoop, Java file? So Kamalji, no. So at the backend, all of these programs are creating your Mapreduce program only. So whatever technology you are using, Pig or Hive or native Mapreduce or Hadoop streaming or anything, at the backend they are creating our Mapreduce programs only. So this compression would be applied in the same phase, or what I'm talking about. It is not dependent to your Hive or Pig, but yeah, definitely you would be using it precisely based on your what kind of processing you are doing on the data, what are your file sizes, which phase you want to apply the compression, and things like that, and which file format you are using. I'll be talking about file formats also in the same slide. So based on the file types also, you will be using you might be applying the compression.
Miraj, is it possible to use multiple type of zip criteria? I mean, depending on the file size, like YouTube, like in YouTube, it's not, YouTube might be using bigger video files and then they should go for gzip, right? And maybe some other image-based companies might have, because they know that their images may not be maximum 10 MB or 20 MB.
Yes, definitely, Rohit. So when your data is coming to a cluster, data as I was displaying in the Excel sheet, data is coming for data warehouse also, data is coming from your web logs also, and things like that. So when your data is coming from different sources, you might be applying different compression techniques on that data. So for images, you might be using gzip. For your text files, you might be using LZO based on the data. So, and while reading the data, you have to just tell the Mapreduce program which decompression algorithm you have to apply while reading the data. And similarly, if I am applying gzip on my input files, I might be applying LZO or Snappy to the mapper output, and again gzip on the reducer output.
Then there is extra requirement to remember also, like what was the zipping methodology used?
You have to know,
decompress, right?
Yeah, you have to know which file you are reading. So if you are reading gzip or bzip, your file extension would be corresponding to that only.
Oh, okay.
So your gzip file will be ending with .gzip, your bzip file would be ending with .bzip, your LZO is ending with, I think, LZ or something, LZO or something. Similarly, your file extension would change. So bzip is but highly CPU intensive as compared to gzip. So LZO is faster as compared to your previous two algorithms, but it also compress your data not as high as compared to gzip or bzip. Compresses less efficiently as compared to gzip. It decompresses about twice as fast as gzip, meaning it's fast enough to keep up with the hard drive read speeds. LZO optimized for speed and are around an order of magnitude faster than gzip. So the compression is less, they are fast. Snappy is from Google. So as compared to LZO and Snappy, they compress our data less as compared to bzip and gzip, but they are faster because the compression levels are less. So these are the different statistics about these compression techniques. I don't know, you can just read them later on. So before going ahead to file formats, now I want everyone to think of, and so I'm just airing this Excel sheet again. So these are the different phases which you are thinking of. Now can you think of which phase I should be applying which kind of algorithm or which kind of compression technique? What makes sense? So that will definitely depend on your data, that will definitely depend on your requirement. But still, there are few techniques which will make sense at particular phases. But definitely that will again depend on your requirement and things like that, and you will be changing them. But still, can you think of which compression technique I should be applying at which at which phase? So say I have a requirement, or say let's think of a system where my data is coming daily. So daily data dumps daily data dumps to my system, and the data dumps are files which so say these daily data dumps are coming from NYSE, and the files which are created daily are for each stock, one file for each stock. So if there are 5,000 trading stocks in my NYSE, there are 500 daily files which are created in my system. And at the end of whole my life cycle, at the end of my reducer phase, I will be transferring this data to some other system, the process data, which will be having some statistics about my, or that will be containing some analytics which I have performed on the today's data, today's stock data. So what do you think, at which level I should be applying which kind of compression over here at these three different layers? So Rohit says gzip. Okay, so I hope, so Abhijat and Rohit says gzip at this layer, I think probably on the input file. So I'll just cut it and put it over here. So you are saying gzip. Okay. And to the mapper output. bzip, Abhijat says bzip in mapper. Okay. Rohit. Abhijat says bzip to the file going to into the mapper. Okay, so you are not saying over here. Okay, to the files. Okay, so third one was LZO Rohit, LZO and Snappy. The fourth one was Snappy. So I'll just write all of them. ZZip, BZzip, LZO, Snappy. So Rohit says LZO in mapper. So I'll give it a green signal. And most of you said bzip over here. I'll give it a green signal. And what about the reducer output? I have to transfer this statistics over to some other people, or which would be looking into this data. So Rohit says bzip on the reducer. Okay. Okay. So now let's see what all I can do and what different compressions which I can apply. So as this is a data which is coming from NYSE for stock trades, definitely the data size would be pretty huge. But what I said is there's a file for each stock. So each traded stock on NYSE. So this so if say in total data which is produced out of NYSE, say 5 GBs or say 20 GBs per day. So that data would be practically coming to me is equivalent to 20 divided by 500. So each file size which is coming to my system is 0.36 GB. So in that case, if my one mapper is reading that file, I might suffice in my system. I am not saying that's a perfect solution, but just I'm thinking in different directions. I'm just giving you how you would be thinking into your system. So I can apply both of these compression things. After applying gzip or bzip, my data would practically become into 0.2. So this is equivalent to this into 1024, and that's MB. So it practically becomes 7.4 MB. So I can think of applying both of these techniques, and my one stock data might be sitting in my one block also. And if it's spill also, that will not be a costly effort for me. D60 looks off. So D60 is the each file size. So if say there are also daily data coming total, and there are total 500 stocks which are traded. So the each file size of my data which is coming to my system is approximately 220 GB divided by 500. And if I am applying a compression like gzip or gzip, my practical file size would be 74 MB. That is what I was saying. Okay, if I divided, okay, sorry. Okay. So sorry for the mathematical mistake. So Rohit said I divided by the wrong number. Yes. So I can think of any of the compression techniques on these files. And if these files are transferring over the network, again, bzip or gzip will make sense to me. But in the mapper and reducer phase, as I don't want to waste much on the processing time, but I also want to reduce my data transfer over the network, I can definitely think of LZO and Snappy. I can think of gzip or gzip also, but that will not make much sense of doing such a high compression of the mapper output and sending it over to reducer, because I'll be using the CPU. I agree to that point, but there are advantages and disadvantages to this part, and you have to practically try it on your subset of the data and look into different timelines at different stages, and then have to think of precisely choose the corresponding compression technique and in which phase you want to apply the compression technique if you are optimizing your whole workflow. So does everyone agrees with this part before I go ahead to the different file types? You have to think of your compression technique, where you want to apply, do you really want to apply, and you have to also try out with different compression techniques, look and monitor the system, look the performance of the system, look the CPU uses of the system. So Abhijat, why gzip over here is what I said is when I'm saying that 20 GB total data is coming to my system, uncompressed data, 500 total files out of this 220 GB data. So each file is approximately 0.04 GB. And if I zip it with the help of bzip or gzip, I am achieving a compression of somewhere. So these are kind of text data. So I'm achieving high compressions. So probably the compression which comes up with bzip and gzip is somewhere from 60 to 80%. I am just assuming 80% over here. So my practical file size became 8 MB. And my block sizes are 64 MB. Yeah, definitely if it's 200 GB. So again, there will be some spillovers. I can think of bzip or gzip. So that's the reason I'm saying you have to think of based on your data, based on your requirement, based on which phase you are consuming more resources, which phase of your system or which part of your system is like idle. So you have to think or choose the compression accordingly. So over here, if I'm using 124 MB block sizes, it's fine enough with me. If I'm using 64 MB block sizes, they might fit in, they might be little spillovers, but the transfer over the network will again be faster because there's only a small part of data which you're transferring. So I might get different results on the data. You have to use the compression technique, try out and find out which is the best suited for you. Avijat agrees with me? So Greece says okay. Spill will not happen, but still 1 MB will be stored in 2 blocks. Yeah, definitely that can happen. 81 MB definitely that will be stored in 2 blocks, and there would be my split would be spanning across blocks. So there would be data transfer across the network for your mapper relays also, and things like that will happen. So you have to think of this might give you good performance because your data is highly compressed, so your IO is reduced drastically. So this might give you better results also. So you have to check and try it out, but now you can understand how that will happen, so you can precisely choose the compression technique at different layers. That is my intention to tell you. Yeah, my block size is 64 MB, that will be as per Rohit. Okay, so let me switch back to the PPT again. So this is an example of Hadoop streaming. We will talk about Hadoop streaming later on. But now you understand that this is configurable thing. I can apply compression at different layers. So in the Hadoop streaming also you have to just define the parameter and the corresponding gzip codec and to compress the map output, and your data would be compressed. So Hadoop streaming is a way to run your Mapreduce program. You can create your mapper in languages other than Java. You can use like Python or Ruby scripting languages, and you can create your mapper and reducer with those scripting languages, and you don't have to compile your code and do things like that. You have to just write your scripting language, whatever scripting language you are familiar with, write your mapper and reducer, tell your program to use those as mapper and reducers, and your program will run on that, and there's nothing like Java comes in the picture. So here I have given the mapper as bin and cat. I think reducer is missing in this command. So reducer would be something like that. So here I am giving the mapper as my Unix command over here. So anything which is coming to the mapper will just be outputted, but I can use a different Unix commands to produce and apply logic on my data. We'll talk about streaming later on, but this is just an example which I displayed over here. Any questions till now?
Viraj, I just have one question.
Yeah.
So Google, like they store a lot of, they index a lot of web pages and they store all the data. So do you think they might be using Hadoop? And because their response is so fast, actually.
So this
Hadoop provides.
Google is only the creator of Hadoop. They have their own file system, Google GFS, Google file system. It's based on the Google file system. Only the HDFS is created, and Snappy is the algorithm from Google only. So they at the backend are storing using HDFS, but where and which phase to store which indexes they are using HDFS, that I am not sure. But they are using Hadoop as a Google file system. So they have their own particular file system which is equivalent to a HDFS. But exactly what is there, I am not sure, and most of those things are not revealed to exterior world also. But in the white paper which they have discussed in Google file system, they are using the similar kind of systems, and in which, so for the indexing part, they might be storing it somewhere else. Where they are storing, I am not 100% sure. But somewhere.
And looking at their response of the Google searches, it looks unlikely, right? I mean, they might be archiving something there, or I mean, maybe when we search something, we get so fast response that maybe Hadoop may not provide that kind of response.
Yeah, right? Definitely the page algorithm is the major criteria behind that. Hadoop is only for batch processing. So the indexing which I created at the backend, Google might be using for this thing. At the backend, they are re-indexing the data. For those things, they would be using Hadoop. But practically,
a cache is created whenever somebody searched with a keyword.
Yes.
And that from the cache only the results pop out. That's why it's so fast.
But practically they are maintaining distributed cache across your web servers, in the web servers across the world, and the distributed cache is making your searches faster. Those things are stored in your distributed cache across your clusters, across your data centers, across the geographies, and that is making that faster. And in the backend, the processing of batch processing, that could be achieved by this kind of file.
Okay.
So I'll move on to the file formats. As I was saying, sequence file, I think yesterday. Let's talk about sequence file today. And before that, just give me a sec. I'll be back in a minute. Just.
So while Miraj is coming back, who all got the access to Ambari?
I got Kamalji.
Okay.
I got it, but when I ran, actually earlier some statistics were not coming actually. Then I ran a job, and then after that it started giving me CPU time and all those things actually.
Okay, that's fine. And is all of you are running on 4 GB RAM laptop, or it is more than that?
I am running on a 5 GB.
Yeah, I'm running on an 8 GB, but my processor speed is pretty low. That's why they've given me 8 GB. The company.
So surprisingly, I asked this question because I am in a catch-22 situation. So what happening is, Arkan is telling me that I need at least 4 GB to run Ambari, and my laptop has total 4 GB RAM. When I go to virtual machine to increase the RAM up to 4 GB, it says that OK button is disabled because I am using more than 80% of the RAM.
Oh.
So either way, it's not letting me do.
Kamalji, yeah, I'm running on a 4 GB laptop and it's working. Ambari is working for me, so I'm not having the issue.
And so Kamalji, I also have not seen this problem with, because lot of the students are using 4 GB laptop only, and they are able to start Ambari. Just try to little bit increase your RAM and try that out.
Well, on the virtual machine, I could increase only up to 3072.
Yes.
After that,
Yes.
My OK button get disabled.
Yes, and that's the reason, because it cannot consume the whole of your RAM.
Yes. Now the problem is when I come back to my Hortonworks website, Ambari button is still saying enable. It is making it mandate that I give at least 4 GB.
And you have imported the OVA file which I have shared. You have not downloaded the OVA, the latest version of the OVA.
No, I am still on 2.1.
Okay.
I'm not on 2.2. Well, we could take it after the class, probably.
Okay. So I'll just mute everyone. Okay. So sequence file, as I was showing you yesterday, in as an input and output file formats in your mapper and user face. Let's look into this. Sequence file are highly used into the Hadoop world, and the reason behind that is they work as a container for small files, as well as they maintain the record boundaries with them. So I'll talk about this slide in a minute. So this is how your a block in a sequence file would look like. It will contain the header, which will contain the information about the sequence file. So header will contain things like keys, the classes, the key class, value class, the metadata about the data, compression codecs, and things like that. And they are in between sync pointers. We'll talk about these sync pointers and the records. And the record, if it's not compressed, it will look something like this. It will contain the record length, key, and value. And if the record is so the record length is nothing but the length of the whole record. The key length is nothing but the length of the key, and the rest is the value length. So record length minus key length is the value length. And if the record is compressed, it contains the record length, key, and the compressed value. The key is not compressed. So this is how at the backend the sequence file stores your data. And the advantage which we get by storing this record lengths and key lengths and header kind of information, our files become splittable. And we can apply compression at both the levels. We can apply the compression at the block level, as well as we can apply the compression at record level. So here I applied the compression at record level. Here I am applying the compression at block level. So if I apply the compression at block level, the block looks something like this. It contains number of records which are stored in this block, the compressed key lengths, the compressed keys, the compressed value lengths, and the compressed values. So I can achieve both kind of compression on these files, and that's the reason the sequence files are splittable, and they are highly used in the industry. So we can achieve both block and record level compression. So, and this sync pointers, so what they help is, if somehow while reading the data, so my pointer is lost, I can resync and quickly reach to a record boundary. So if you recall your childhood days, you would be playing your music on those tape recorders, and you are pressing forward and rewind to reach some particular song. So same way over here, I have to seek the particular record boundary, but the help of these sync pointers, I can easily go to a record boundary. So there are sync pointers in between records, and these sync pointers would be there at a particular frequency after the record, and we can easily find a record boundary with the help of these sync pointers. I'll show you an example how those looks like with a code thing, but you can create your sequence file in HiveWord also, QuickWord also. All you have to just define the file output type. So like we use the file input type as text, we have to use the file output as a sequence file, and your program would create a sequence file for you. So, but for the explanation in this class, I'll use the Java code to write a sequence file, to read a sequence file, and to show you the beauty of the sync pointers. So, okay, I think this is a chat from Avjat later on. So that was the previous chat. So let me open the console. So I'm on the console. Let me just delete the output directory before creating a sequence file in the output directory. So I'm just deleting the output directory from the UI rather than deleting it over here. So I have a Java program which will create a sequence file for us, but you will not be using the Java practically. So what I'm doing in this program is, these are different records in my file. 1, 2, buckle my shoe, 3, 4, shut the door, and things like that. And I'm randomly placing these values and creating a sequence file where my key is my row number and my data is these values. And I'm writing it to the file. So I'm just creating a sequence file where my key is the row number and the values are these things. So let's try to run this program and create a sequence file. So while writing it, this program also writes it on your console also. This is what is written in your sequence file. So other than the sequence file information, it also wrote the byte offset of my records. So the position of my records in my file. So it also written the position of my records in my file in the brackets. This is not stored in the file, but this is the position of my records or the record boundaries. So the record is starting at this position, this record is starting at this position, and so on. What I was displaying in the previous picture. So now let's try to read this file with the Hadoop fs minus text. So text is a command by which I can read my sequence file. So if you look into the sequence file which is created for us, there just contain the key and value pairs. And here I have just created extra information, that is the record starting position. Now let's see what is the beauty this thing gives to our sequence file. So let me read that file with my record, the sequence file reader. So I have another program for reading the sequence file reader, but what I'm doing in extra in that program, I'll just show you.
So what did your previous command do? Hadoop fs minus text.
So that is reading the sequence file. If I say Hadoop fs minus cat and will read this file just contains junk characters for me. So these are just the junk characters. So I am just converting those junk. I am converting those junk characters. I am reading those junk characters. So the file is in some other format, which is really. I'll just put you on mute. So you can unmute you can unmute when you want to speak. So what I'm saying is this file is not in a text format, and this minus text is just converting that to text format and displaying it to me. So that's the reason I've written my own reader and writer in the Java code to display those files to you. So let me read that file what is written over here with my Java reader. So other than the record starting position, I am also printing stars in my starting position, and this star is the sync pointer which I was showing you in the picture. So I'll go back again to the picture to refresh that thing to you. So these sync pointers, I am also printing these sync pointers with the record boundary. So record starting position, if that has sync pointer also, I am printing that there is a star in my output. So there are two sync pointers in my whole data set. One is 2021 and another is at 4075. So these are two sync pointers which are highlighted over here. So these records are also have the sync pointers. Now how they help, let's look into this. So I have another Java program, but you will not be using Java program to read those things. You will be your Hive and Fake would be reading those files, but I'm just telling you what advantage I get. So this is a program where I just give the record starting position and I can read that record. So I'll just give to this program the record starting position and I will read that record. So let's give some starting position, say 3075. And it will read that record. So what it will do is it quickly go to that position and start reading from that position. So now to start reading a record, it has the header of the record to read the whole record. But if we start reading from in between the record, so if I say start reading from this position, it will not find the header information and things like that, and it will not be able to read your record. So now what is the beauty which I get with this sync pointers is I can resync my record position. So I have another program which I have created. So in that program what I'm doing is I am resyncing my position. So if I see I am lost, I am using the sync pointer and resyncing my position to a record boundary which is nearest to what I have given as a rate, and I'll start reading from there. So this is a program which do the resync for you. So if I say 403889, 3889, and in between that say 3884. So it will resync the position or the header of my record, or what I say in the cassette, it will resync it to the start of my song. And it will start printing my new star from the start of my new song. So see, it has resynced to 4075, which was a sync position, and it's printed this record. So this is how syncs are used while reading your data when your different technologies would be reading this data, and it becomes faster to read your data. And as the files can have record and blockable compression, these files are splittable also even after using the compression technology. So now you can think of, even if I use gzip on a split file, my file will be splittable. So even I can use different compression technologies. All I have to think of which level I have to apply that compression. If I am applying that compression record level in my split file, my data is again splittable because of the beauty by which the data is stored in a split file, and I can use a higher level of compression. Does that make sense to everyone? Okay, Grish says yes. Rohit says not all. Okay, Rohit, what is the question you have?
So, Miraj, actually sync, I mean, what sync is doing when you resync, is it like building new indexes?
No. It's not building new indexes. The sync is just a pointer. So sync is nothing but a pointer. So if you let's think of in the terms of this is my cassette which has the songs. So this is your one song. I'm just giving a random example which is coming to my mind. So this is your one song, and now my cassette is stopped at some at this location. So what I do is forward, and I play over here, and now a new song has started. Reverse. I play over here. Oh no, the old song is there. Somehow I will reach this position. So the sync pointer are nothing. They are just I know where my sync pointers are there with the help of sync which is available in the sequence file. How that is practically implemented, physically implemented, I am also not 100% sure. But the sync becomes very fast. If I say sync, my pointer will directly come over here, and I can start reading from here. So now I am at the start of my new song, and I can start reading from here.
And what you told, does this apply to only text file, or it applies to any
record,
video or
any record? So that's the reason I said the sequence file are used as a container across the industry for smaller files.
Okay.
So, and the reason is they maintain the header and the length keys and values. So you know their record boundaries. So you can put any kind of files in these sequence files. So this value will contain the video in that case for you. Any other questions? Okay. So map files are similar to sequence file. Only one thing extra they have is they also index your data. So what they do is let's look into the let's look into this again. So I have again a Java program. I have again a Java program which will create a map file for me, and I'll just show you the map file. So yeah, this is a Java program which creates a map file for me. So Hadoop zar. Okay, I'll copy this class name for me, and we'll try to run it. So and go back there. So I'll just change the, so before that I have to delete the output directory also. So that is not a directory in this case, that was just a file which was created by the name of output. Okay, so
Miraj, why do you have to delete the directory every time?
Because Mapreduce output is so I'm just running it with the
same
Hadoop
file all the time.
Yeah, I'm just putting it in the same file or directory. You can use different files every time, but I am just putting it from the same file. So
and second thing, I see that you are running same jar file. So does that jar file have a lot of objects and
that's right.
different
Yes, that's the reason I shared the jar file also with you, and that's the reason I have not made this jar file executable. And the only reason behind that is you can execute different classes which are there already in this jar file. So all the classes which you can see in your Eclipse project inside your Java code, all those are compiled over here. You have to just give the fully qualified class name and the corresponding input and output parameter what that file takes, and you can run it. So that's the only reason I have not created this executable jar. Otherwise, this would have been intended to only one of the classes in my whole Mapreduce code base.
Okay.
So I'm just trying to write a map, map file with my Java program. So This map file is also doing the same thing. It's writing this data randomly and giving the key as 1 to the row number, 2 to the second row number, and so on, and writing your data. But if you look over here, Hadoop FS minus ls output directory, there will be two files. One is index file and one is your data file.
And what does ls stand for?
List in Unix.
Okay, and then the first one you said Hadoop FS minus RM is read memory?
No, RM is remove.
Remove, okay.
So there are two files. See, one is the data file that contains your data and one is the index file. So let's try to look into these files. Hadoop FS minus text, and let's first look into the data file. So see, it has the data and the key and the value pairs. Now let's look into the index file. So it's similar to the indexes which you create in your RDBMS Word. Only the thing is, all your data is not indexed. Only the index are of your records at a particular frequency. So it has the key 1 is at position 128. Key 1 was at 128. This has gone up. Then 129 is starting from 6078. 897 is starting from 41992. So 897. 897. 897. So this key is starting at this location, and so on. So it's just maintaining the index also at and not indexing all your records, but indexing your records at a particular frequency. So now if you have to look for a key, say 600, you will be looking into the index file and you will find out the position of 513 record. That is starting from here, and you will start seeking from this position rather than seeking till this position. So your seek becomes much faster with the help of map files, and it stores your data similar to a sequence file. So you get your data index also with the help of map file, other than your sequence file benefits.
Viraj, one more thing. Other files, other outputs you have always done Hadoop FS minus cat, but these files you have to do Hadoop FS minus text. What is the difference between the two? I'm
converting this file to text. Just practically this file is not in a text format. So if I say cat,
okay.
This file is not in a text format.
Yeah. So those files were in text format. They were written in text format, right?
Yes, those were in text format, but these are using native how the sequence file is basically writing your data.
Okay.
So this was the map file which I was talking about. Then RC files. This would be interesting for all the people who are related to data warehouses. This file format would be interesting to you. So if you can remember and think of how the data is stored in RC files, in your databases. So if I look at a particular table in my database, say, we might extend 10-15 minutes today to just complete this topic. I hope that is fine with everyone. No one has to rush after this class or go to bed. If we extend 10-15 minutes this class.
That's okay.
Okay. So if anyone has to rush, just ping me up. We'll just extend it 10 minutes to complete this whole topic. So say I have my employee class, employee table only. So that contains the employee ID, employee first name, last name, department ID to which this employee is associated to, address, and things like that. So the data which is stored at the backend in the file system for you is something like this: employee ID, name, last name, department ID, address, employee ID, first name, last name, department ID, address, and things like that. So this is how your data is practically stored in your RDBMS world. So your data is stored row by row. And when you have to seek some particular row, you have to traverse something like this. And then here, and then here. So file is practically not like this. File is written sequentially. So a file would be something like this. A file would be looking something like this. It will not be something like this. It will be practically looking at the data. These records are written. So you have to traverse it something like this. So your files are written row by row. But what is the beauty? What is the beauty with which we get with a row file format is we, rather than storing your data row wise, we store our data column wise. So rather than storing my data something like this, I store my data something like this. So I think
can't see your Excel sheet.
Oh, sorry.
Same here.
Oh, okay, sorry. Now? Now can you see?
Yes.
Okay.
Yeah.
So what I was saying is, so you were able to see till the point I shown you how the data is stored into your RDBMS word, or shall we go over there? So what I was saying is, in your RDBMS word, the data is stored row by row, and I'll just quickly show you also that. So practically the data is stored something like this in your RDBMS word, and that practically your data in the file would be like something like this only. After this record in the file, your data would be something like this. So you are traversing the file something like this. But when I use row column format, I do an vertical partitioning of my data on columns, and my data is stored something like this. So 1 and 23, MIR and DF, DDF and ETR, and like this. So I'm storing my columns together. And can you guess what are the different benefits which I'll get by storing my data like this in a column based rather than row based? So this is your row file, RC file. And this is your original, how you store your files in your RDBMS word, the row based storage. Can anyone think of what are the different advantages which I would get if I store my data in the column format, basically partitioning your data vertically rather than horizontally? Abhijat says retrieval is faster. So how you think retrieval is faster? So Abhijat, I'll not buy your point. So I'll not buy your point. So Akash says possible to index the data record. Indexing I'm not talking about. Indexing I'm not coming into picture.
Is it related to split, Miraj?
No, I'm not coming to split part also over here. So say I have to run a query, select department IDs from employee. Employee where department is greater than 10. So now, rather than traversing it like this, and then here, and then again going to the department column, all I have to do is start traversing from here, search over here, the department which are greater than 10, print them. So when I'm searching particular columns from my data, these files are very fast for me. So when we'll be looking into the high-based structures on our data, you will be highly using these RC file formats.
So our question on it, yes, understood. If we are doing a search only by column, but the minute we add the second column, the complexity increase.
No, the complexity will not increase high as compared to your other data set. So if I say first name also, the complexity will not that much increases, because all I have to do is I know the position of that record also. I know which the first position. So if I'm saying over here greater than say 30, so I know this is the record which has this thing. So all I have to do is now traverse to the first name records, and I have to just get the second record. So complexity a little bit increase, I understand your point, but my data seek would be faster.
Viraj, that's actually a blaster for all my RDBMS thoughts. That I have record by record, the overall, the way metadata is stored, I could definitely get a column map information very quickly. Now entire column merged into one record, and the records are by column.
Mm-hmm.
So
okay,
it is still goofy for me to clear, accept it that it would faster.
Okay. So Kamalji, just wait for 2 more slides, and then I'll again come back to you. So,
but Mira, just one thing. So the table which you are showing, when it is written to the database, to the disk actually.
Yeah.
Anyway, on disk it is, there is nothing like table or anything, right?
Yeah, it's something like this. Yeah. It's something like this only.
Yes.
Yeah. So, but I know the starting point.
Only benefit is you know when a particular column is starting, and you are searching that column. In that area itself. Yes. You don't have to jump a lot of values. Right?
Yes, jump a lot of values when I'm selecting some particular columns and not whole my data set.
Oh, okay.
Okay, and Kamaljeet, I'll again come back to you. Just wait for 2 more slides, and I'll again come back to you. So now these RC files not only partition your data vertically, they also partition your data horizontally. And now let's come into that complexity, and then Kamaljeet, I'll come back to you. So this RC files not only partition your data vertically, that is column by column, they also partition your data horizontally also. So they partition your data like this also, and they partition your data like this also. How? Let's look into this. So say if this is my table, they create row groups. So my row groups is all configurable thing. Here I am saying the row group size would be 4. So my 4 columns or 4 rows will be horizontally, vertically partitioned, and another group of 4 will again be vertically partitioned. So this is how your really data is stored. So we create blocks of rows, and we break those rows vertically and store them. So while traversing the records, I can skip the row groups. I can look into the row groups. When I'm doing a where clause, and if say my where clause is on column 3, so I am traversing the row groups only for column 3. And if something matches for that column 3, then only I will be reading those corresponding columns which I am reading. So if I am reading C2 and C1 also for that particular match in the where clause, I'll be reading those things in that case only. So these RC files not only split your data vertically, they also split your data horizontally. So this data would be written something like this in your file system. And I'll come to all these slides in a minute. So practically this is how it is written. So these are your boundaries. in row oriented system, in column oriented system, here are my boundaries and the position. So not only the data I'm storing, I'm also storing the position of that column. So if I say a where clause salary is greater than 5,000, so I'll go directly to the salary block, or sorry, so from where the salary is starting. So I'll quickly check the row number 4 is only having the salary greater than 5,000 or 50,000. So, and I just want to print the name. So now my pointer will come over here. I'll come to the row number 4 and will print only Jones. So Kamaljeet, now I am coming back to you. Does that make more sense?
Yes, I'm still trying to digest it, but still trying to understand it, Miraj.
Okay, yeah, I can understand there would be a difficulty to digest this concept, but here we are dealing everything in the file system. We don't have systems like Oracle which are doing all the backend processing for us, optimizing our queries. Optimization happens in Hive also, but such kind of systems are not there. All our data. So we have started from file system in 1970s and 1960s, or I think even prior to that. We came back to RDMA's world. We came back to the world where we wanted to normalize our data as much as possible. Now we are again coming to the world to the file systems. We don't like normalization. We try to put our data highly denormalized. So we are again coming back to that same era.
Pretty good way.
So you will see the benefit of these files. Try to use these files in the Hive world and then see the benefit of using these files.
That's right. We need to put some more hands together to understand it better.
No. But if you understand what are the different file formats available to you, then while writing your programs, while writing your data, or while reading your data and writing your data into the file system, you could be precisely choosing the file formats and the compression technology. So now this is one advantage which we have seen of storing our data in the column oriented structure. There is one more great advantage which I will get if I store my data in column oriented fashion. Can anyone think of that part?
Can we introduce indexing with that?
Indexing, practically indexing, I never personally use in this world. Although Hive supports indexing, but indexing does not give much advantage in this world, because the way indexing is applied in your Oracle world, they try to implement it in the Hive part also, but practically we don't achieve such kind of benefit. There are other things like partitioning and bucketing which we can apply in Hive, and that helps you in the faster processing, but practically indexing I have not seen any practical good uses of indexing my data.
Okay.
So if you think in the terms of compression, the compression is applied on your bits and bytes. So what compression does is it looks in your data quickly. It tries to find out the similar bits and bytes, and then based on the similarity in your data, it tries to compress your data. Higher the similar your data is, higher the compression you can achieve. So now if I'm storing column by column in my blocks, or in my basically column by columns, my data is similar in the columns. And if my data is similar in my columns, I can achieve higher level of compression on my data as compared to my row oriented systems. Do you agree?
Yep, that's right.
So that is another advantage which I get if I store my data in the column oriented. So they not only do the vertical partitioning, they also do the horizontal partitioning of the data. Okay, so There are other statistics which are also written over here, nothing great. So we do horizontal and vertical partitioning of my tables. The horizontal partitioning will partition the first columns. So these partitioning row group sizes are user defined. So the row group size was nothing but these sizes. And this is how your data is stored. And the compression which I was talking about, the compression algorithm can be selected. So when I'm doing a query on particular column, my IO cost is very less. Not the IO cost, but the seeking cost is very less. So there's something called ORC which is available in the latest version of Hadoop Word, that is Hortonworks 2.2 has introduced ORC file formats also. And ORC is a label on top of RC file formats, the row columnar formats. And I'll not go about the complexities of this file, but I'll show you the file, how the file looks like, and what are added advantages of using ORC. So other than they split your data in a column-based format, they also maintain other metadata with your data. So they maintain the indexes with your data. So with the help of what these indexes has is they contain what is the min and max values of different columns stored in this block. So if say I'm storing the previous data where there was salary also, so here in the index I'll be maintaining the min and max salaries in this record. Or sorry, in this row data, not record, in this row data. So when I'm running a query where salary is greater than 50,000, I'll be just reversing my header and will quickly check whether there are any records which are having salary greater than 50,000. If they are not records, I'll not reverse this whole row data and I'll skip this row data. So they maintain not only the data, but they also maintain indexes and other things with the data. And by this way, we get basically faster processing on our data when we are dealing with the data in a column-based format. So there are also different things which this ORC file stores, and ORC file contains group of rows data called stripes. So these are different things related to file system. The default strip sizes and things like that. They also maintain the metadata and the file footer. So this talks about the metadata about the whole file. But the main beauty of this files is indexing the data with your row data. So Kamaljeet, now does that RC makes more sense to you?
Yes, Miraj.
So this is so if you use ORC, our processing of data or searching over the data will be much more faster by indexing the data only for that row data. So only for particular row data, I'll be indexing my data. So here I'll be just maintaining the different statistics about different row data which is there in this data, and thus my processing would become much faster. Then there are Avro files. Avro files will also be listening a lot in Hadoop Word. So as Hadoop was written in Java, the files which are produced, so or what I was talking serialization. So if I serialize my Java objects and put into your file system, those objects can only be read by Java. However, they are platform independent because Java is platform independent by native. So those objects are platform independent, but those are dependent to Java. So this was a major challenge which dog cutting was facing while using or while writing the objects which are outputted from your Mapreduce programs and other programs. Those were not although they were platform independent, but they were not language independent. Also, there are different features which are available in the Avro files. So these files are not only language platform independent, these files are also language independent. So our object written by Java can be read by Ruby, our object written by Ruby can be read by C++. So this Avro is not only platform independent, but they are also language independent. They have the language portability. Moreover, these files are splittable. The way these files are stored in the database, in the file system, these are splittable, and they contain the metadata about the data also. So you can think these files something like JSON. I hope everyone knows what is JSON. So you can think these files something like JSON. So they not only contain the data, they also contain the metadata, what is the column name and the column name and the column value. So the added advantage which I get with these files is, say I have changed my file structure. I have added one more column to the to my data. So I'll switch over to Excel sheet. Just a minute. So my data would be something like this. With a transpose. Okay, so with the data, so this is how my record will look like, something like this, similar to somewhat JSON. So I'll also contain the metadata of my data. So say at a later point of time, I added one more column to my employee family, and that is say employee city. So some of the data which will be written with the previous version of my code will not have that city, and I can't process whole terabytes of data and add the city, and that is not possible also, and that data will also not be available for me. But the beauty about Avro files is, based on the metadata on which you are reading the file, only those columns would be written to you and others would be easily skipped. So if I'm reading this data with the previous version of my Avro metadata, this city would be skipped up, and the records which do not have the city, those records will also be read from you, and you will not get any error. And while writing, also same logic applies. If you add more metadata, that metadata is stored with your data only. So you can read your data and write your data, and even if your metadata changes while reading and writing, as the metadata is stored with your data, you don't get issues while reading and writing the data if your metadata changes from the previous version or what you are using right now. So not only these files are language portable, platform portable, but these files are also splittable, and they also contain the metadata with the file, and while storing the metadata with the file, we can change the schema, and the change in the schema does not affect our read and write process. I don't have a picture of Avro file over here. I can't show you that thing. Yesterday someone asked me that thing, so I'll try to get something for that. But this is the advantage which I get from the Avro files. So these are the different compressions which I can achieve by using different files and different compression technology. There's a picture copied from somewhere. And Avro files support different data types. Long, boolean, float, double, bytes, strings, and they also support different complex data types like array, map, record, enums, and things like that. So you not only store the regular text, but they support different and complex data types. So you can store the data in different complex data types in the Avro files. So any questions? Anything which you want to discuss on the compression side, file formats. So these file formats you have to precisely choose while you are importing the data, creating your data pipelines, producing. So if say my pig is filtering my data, I can produce RC files on that data, and I can create a table on that RC file with the help of Hive. So the reads on Hive and the queries which are running on Hive could be faster. So based on my data which I am dealing with, based on the life cycle of the data, based on the type of data which I'll be dealing with, I'll be choosing precisely my compression technology, my file formats. If I have to transfer my data to other teams, I might be using Avro because my schema might be changing frequently. I might have to transfer the data. My data is also splittable. I can compress the data also. So based on your requirement, you would be choosing different file formats. So, any questions from anyone? Okay. And I think Rupal would have sent you an email. Yeah, we're just trying to rebuild. Yeah, we are just trying to rebuild our website and getting feedback from our previous students and the current students. So it would be great help if you can just provide if you feel if everything is going good.
Otherwise, we are not welcome to provide.
No, you are most welcome to provide any kind of feedback. But for me, you will be writing that for me.
No, things are going really good.
Yeah, sure.
So you'll be putting up this presentation after, since we are seeing the last slide, right?
Yes, I'll be putting both that this Mapreduce one and all this file format also. I'll put it in the shared folder. Yes, I'll put it over there. So Girish, let's talk in somewhere in the data time, and I'll try to resolve your problem. I will do join me or something, and we'll try to resolve.
Okay. What time do you have in mind?
I'll get your number from Rupal and I'll give you a call. Will that be fine?
Oh, that'll be great.
Sure.
Oh yeah, absolutely.
I'll take your number and I'll give you a call.
Oh, I'm at home only, so anytime. I mean, today is holiday, so I'm at home. Anytime you can just give me a call, and then I'll immediately go down to my laptop.
Sure.
And I will be able to fix it.
Oh yeah, so today is holiday in India. This is a Republic Day.
Yeah.
So
Yes.
You
Happy Republic.
President of America is here, so got to watch him here.
Sorry?
Obama is here, right? So
Yes. Yeah, I was just thinking of to open. Yeah, after the session, I'll just open the television and see what are the kind of security. So there's a high security alert across the Delhi, and people, it took on Friday evening, Friday morning, people took more than 5 hours to from Gurgaon to Noida, which is 1 hour. Yeah, because of these security alerts and things like that. So there's a high alert over there. Okay then, guys, thanks for your time, and let's meet.
Thank you.
And then in the next class, we'll look into the yarn, how the yarn is different from your Hadoop 1.x, and then we'll switch over to Hive. So that will give you a real picture of the system, and then we can look at the Hadoop streaming after that Hive and pick.
Okay.
Sure.
Hey
Okay.
Miraj, so I have the other problem.
Okay. Yes.
There's some time I could.
Yes. So Kamaljeet, either we can stay right away, or if you want, we can sync up in weekday also. Whatever is convenient to you.
Right away is the best preference for me.
Okay. Sure. So if you, I'll give you the control and I'll see your desktop, and others, if they want to leave, they can just leave up.
Yeah, sure. Thank you, and have a good day.
Thanks. Thanks everyone.
Thank you everyone.
Good night.
Thank you.
Bye.
Bye. Good night.